Okay, so it's 3 o'clock on a, I think, Wednesday afternoon, and it's time for GSE 2020 session 5AZ, and that will be provided by Dan, who I will hand over to shortly. Just to remind you, any questions to go in the chat, and we'll deal with them either during or at the end of the session. If you feel up to it at this time of day, maybe you would like to give feedback on the session when it's complete, that would be greatly appreciated, both for Dan and also for the GSE committee, who do read all the feedback in order to help them to set up the sessions for next year, hopefully a face-to-face version. Okay, so without any further ado, I will hand you over to Dan. Thank you, Dan.
All right, thanks, Anna. So my name is Dan Wiggins. I'm an offering manager at IBM, and I'm here to talk today about a couple of things that we're doing to integrate IBM Z into enterprise solutions for hybrid cloud visibility. So we've been talking about the digital transformation that's been going on for quite a number of years now. And, you know, as everyone is heard by now, I know every company has their own digital transformation slide. It's, you know, largely been led by the pervasiveness of mobile devices and, you know, real-time access to everything. And a lot of what IBM has been doing is talking more and more about hybrid cloud, and IBM Z is such a large part of hybrid cloud. You know, we can't think of the entire ecosystem of things that we do on a day-to-day, whether it be banking or kind of pre-pandemic when we were traveling, or even retail. All of those applications that we're driving either from our PCs or our mobile devices largely end up impacting or running transactions on IBM Z. And there's still a large number of challenges that a lot of our customers are facing. And as this kind of continues to grow with momentum, you know, we see a lot of our Z customers wanting to maintain or grow their usage of the platform over the next 2 years, and really again as part of this hybrid strategy. And you know, we see a lot of different changes that have happened even over the last 6 or 7 months here, as much of the world has gone digital. Our workloads and things have really changed in terms of how we're going and interacting with different platforms. And to this point, a lot of our customers are trying to develop an approach to resiliency in terms of their operations. And we can't just start looking at things in silos with IBM Z on one side and the enterprise applications on another, because these are really part of a larger and broader ecosystem. So if we look at a couple of the things that we're trying to do, and this presentation will tie into one of the ones that I'll do tomorrow as we start to go into machine learning. But this is really looking at how we bring IBM Z in, again, as a first-class citizen, as part of this hybrid cloud. And we really want to be able to detect operational issues and anomalies as part of a hybrid application. You know, we start talking about how AI starts to go down this path, and so that we can start to, you know, look at predicting the future and how we take action and automation eventually. And where I know a lot of our customers have been in terms of how a lot of their operations is getting into this firefighting mode, where, especially if we're talking about enterprise applications, where issues are identified by a lot of external users. We really don't want to get into the place where our users are finding problems with our business applications before we can find them through our monitoring tools or our AI operations tools. And it's kind of funny how things have evolved over time. And this kind of goes out to some of those statistics that are up there is, if you look at when a large service goes down, whether it be um, a banking thing or something, maybe an airline or retail, the first thing that folks start doing now is taking to Twitter or social media to start to interact with your help desks. And this hasn't always been the case. I know there was a period of time where you would pick up the phone and wait on hold for 30 minutes, an hour to reach to someone in customer service, or send an email and get a response in 2 to 3 days. Go and look at, when you start seeing reports of, kind of systems going down, go out and look at those companies' Twitter pages, and you'll see them stacked up with folks, just tweeting at those companies. I know this happened roughly a year and a half ago. I was in Atlanta for an IBM Z technical university, and American Airlines had an issue with some of their reservation systems. And true enough, their entire Twitter page was filled with people tweeting about not being able to access the reservations. And the culture now is really to get that immediate response. And we get into these modes of firefighting and trying to find out what the problem is. And we end up in these war rooms that are a large waste of time for everybody. So if we look at our enterprise IT ops person, she might be seeing all of these tweets that are flying in, and she has an issue with her application. And without visibility into the entire stack as to what's going on, what's going to end up happening is she calls up her 10, 20, or 30 closest friends to all check in and start seeing, reporting that maybe our cloud systems are okay, our Linux platform's okay, there's nothing going on in the network. We bring in folks from MQ or Kix, and this really turns into a mean time to innocence call. So everyone's trying to say, it's not me, it's not me. That's the problem. And through my development career at IBM, I supported one of, from a development or DevOps perspective, one of our cloud hosted applications. And these kind of situations are never fun. They don't occur at 10 a.m. like it is here for me now, after I've had my first cup of coffee and gone through my email and sat down to start my first war room of the day. They typically happen at after a change window, maybe late on Friday evening or over the weekend, really where we start seeing a lot of impacts at the worst time. And ultimately we get down to is when we finally get up to the culprit, that it might be something in a database, that a transaction is waiting on a lock and it's impacting the response time. And what we just did was we wasted all of these folks' time in how we go and, get to the root cause of an issue. And again, a lot of these things are off working in different silos. For quite a while, we've had our traditional resource monitors. Those are great solutions. They're not going away. But again, this kind of breeds the perception of we have different things in different places on different sides. So if we're looking at this from an enterprise IT ops standpoint, we can maybe see that our Kix SME is starting to see some storage violations, and we need to go and take a look and do a quick fix in this. But what's if we don't have any kind of integration with the enterprise, the IT ops person might see kind of that ghost in the machine effect, where something's going on. We were starting to see transactions response time spike or start to fail. But all of a sudden it's gone away, and I don't know what it was, but everything seems to be okay now. So I'll just kind of hope that it's not going to come back. And really where we want to get to is to have these teams working together. So our IT ops person might see a slowdown happening in processing Kix transactions. She likely and very likely has no idea what CICS even is. She knows it's part of that mainframe, the big black box that sits in the middle of our data center. But I don't know exactly what this is, but at least I know where there's a potential issue or problem. And if she calls out to her kick sesame, he can maybe say that, hey, thanks for the notification. I've already seen these storage violations. I can go and make that same fix that I saw after being alerted from our resource monitors, but at least in this case, we kind of know from an end-to-end perspective what's going on. And from the enterprise IT ops person, she's probably being asked by her lines of business or application owners, why are we starting to see these kind of things? And without the enterprise visibility, she really doesn't know what that goes and looks like. So part of the best practices and things that I'm going to talk about today is really about how we bring IBM Z into this broader hybrid cloud and really make it visible as the key piece of the infrastructure that it really is. And there's two things that I'll talk about as we go through the presentation today. One is how we integrate with application performance management solutions. And then the other one is operations analytics, or some of our log analysis solutions that almost all of the Z customers that I talk to, they have some of these solutions deployed across their enterprise, if not multiples of the different types. And it's really around helping to avoid those war room situations where we can quickly identify where things might be happening, and getting out of this having this black box that could be IBM Z in a lot of cases, in a lot of our customer environments. And we really want to get down to where we can find as much information so that we can hand over to the appropriate folks as needed. So if I go ahead and start, the first kind of dive that we'll do is into the application performance management space. And as Anna mentioned, if you guys have questions as I'm going through, please go ahead and type them in the chat. I have the chat window up on my other monitor so I can see them and answer them kind of in line. So one of the big challenges that we have with the market leading APM vendors is they lack any support for IBM Z. So according to Gartner Research, who I know a lot of you use as kind of the go-to for looking at evaluating top solutions, 13 of the 15 top APMs don't have any integration into IBM Z. So if we go and take a look at this screen, which happens to be an App Dynamics console, the key thing that I want to draw your attention to is the red circle that's there. So the APM solutions are very good at mapping out the topologies and transaction paths that all of our key business applications happen to take. This one is actually a nice small and contained one. They can actually become quite complex, but we can see that we know the number of milliseconds that these different calls take, all the different hops between web services and web containers and databases and network and JDBC. So all of those things come together into this topology map to trace a transaction that's coming from my mobile device all the way down to, in the big problem we have here is that red circle, it jumps off into a gray area that is CICS. We have no visibility into what's going on in IBM Z from a total topology standpoint. So if you can think of someone running in your operations center, they have a wealth of information about the rest of their hybrid cloud environment, but they get down to having nothing when it gets down to that most important resource that's in that environment, which is IBM Z. So one of the challenges that we're trying to fit into this is to bring that next half of that data into this platform. So we can see that we have our web service that makes a call out to a Java container. It might go down into CICS or into IMS through IMS Connect, and we complete a large part of that puzzle that has been missing. We can kind of see different inbound and outbound things that are going on and off of the platform. And this is really designed to, if you think of having all of this extra data and information there, if we start seeing slowdowns, we know, hey, maybe it's not actually IBM Z that's the problem, which in a lot of cases it usually isn't. We don't have to bring in our mainframe team to go and prove their innocence just because they're a black box and have no visibility into that platform. So what we're really trying to do is, and we'll see this as we talk about the operations analytics side as well, is bring IBM Z and at least some level of visibility of Z to the platform. Are these folks going to go out and be able to go into the deep dive tools and things, or be SMEs? Probably not, but at least they have some information that they can go on to either rule out, is this a Z problem, or we at least maybe know where to isolate and who to call without getting into that firefighting situation. So let's take a look at how our application performance management connect kind of works. So we have an agent that's running on ZOS, and it's going and collecting all of that transaction data. So it's adding a token to a lot of the inbound calls that it can trace through IBM Z. So what it will do then is take that data, put it out to our distributed gateway, and then it sends it out to the APM controller, where it can go and complete that part of the picture. The nice thing about the topology, especially the distributed gateway pieces, is a lot of what we're doing is moving towards containers. So we can go and do a quick and easy standalone VM deployment with Docker and get something up and running just to go and do a quick test. Or we can start looking at OpenShift and Kubernetes to really start building out a enterprise type scale deployment of the solution. So just to quickly talk about some of the transactions and transaction paths that are supported today. And this list has grown significantly over time. And what we kind of quickly found is, as we're going in and working with our customers who truly value this, is that there's really a lot of different paths that you folks have as you're starting to bring together IBM Z as part of these applications. So we have transactions that flow through MQ, right? We can put something on a queue and it gets pulled off, and then goes and runs a KIX transaction, which might call back out to IMS or MQ again, or some other outbound server. We have the KIX transaction gateway or the transaction server, even ZOS Connect coming in and putting information into CICS. So a lot of different entry points that our customers have used to go and trace down through a lot of these transactions. And it's a very similar picture that we have for IMS. So coming in through an IMS client or IMS Connect down to IMS. And there's some things that we can only support through the IMS MQ bridge down to the actual database level. And it's really just the way that we go and process the tokens and things like that. But the interesting thing is, in doing all of these different paths, is the data that flows up to these application performance management solutions. And if we look at kind of across the stack for KIX, we can go and see the task number, the user ID, the transaction name, who's the inbound caller, if there's an ABN code, if the transaction fails. Similar data for IMS. So again, looking at the times, the transaction names, and ABN codes. ZOS Connect is a very important thing for us in terms of opening up the API economy on IBM Z. And we'll see this when we talk about the operations analytics space again. We can look at the request ID and the service names and the methods of accessing the services, whether it be a GET, a PUSH, or a POST. What the response code is that's coming back. So a lot of this information is here such that when we go and bring this up to that APM view, our IT operations person can come and say, hey, there's a slowdown that's happening in Kix. I can give you the exact region name and the task ID that is associated with it. And she can provide a link into that picture that I had shown. So, the Kix SME can go and see the big picture on how this all works. But, by and large, he's likely to go down and use his tooling that's on platform that he uses on a day-to-day basis, such as the Omega Mons, to go in and look at the task history or everything that's been going on within the resource monitor, so that he can go and take any corrective action that's needed. So we're really having these two teams, and the idea is that they start to work hand in hand together. And this is something that I know has been a challenge for a lot of our customers. Just in talking about how a lot of our solutions are deployed together, that the teams and things are very siloed within a lot of our customer organizations. And really to really take advantage of this new hybrid cloud world, we really need to start working together. And the next thing I'll talk a bit about is our operations analytics solution, which is a slightly different approach than using an APM solution. So this is how we integrate operational data and metrics from across the enterprise into a single location. So this is using tools that are out there like Splunk and Elasticstack. And just to kind of tell a quick story about an engagement that I had done about a year, 2 years ago, to go back to these silos, is we were doing these kind of roadshow of lab events where our customers could get hands-on. And the IBM office that we were in, the large conference room we had a table that was in a giant U shape. And one of the largest financial customers that we have here in the US was in attendance. And on one side of the U, they had folks from their IBM Z team, and across the open area on the other side of the U, from the same customer, they had folks that was from their enterprise team that runs and manages their Splunk environment. And we started the call off by going around and doing introductions, and they quickly realized that they're from the same company and they were both given the same mission from different places. So it was interesting to watch them have a conversation for 20-30 minutes, just to go and talk about the importance of bringing mainframe data for them into their Splunk environment. So, getting those teams to work together was, kind of an interesting thing to kind of see unfold right there. And it really aligns to really why we're doing a lot of the things that we're doing with IBM Z and bringing that into these enterprise solutions. So in terms of operational data, so think of this as all of your SMF and log data, everything that you might want to go and look at when understanding how IBM Z is going and operating based on all of this digital exhaust or log information. IBM Z is one of the most well-instrumented platforms that's out there on the planet. And we need to get access to all that operational data in order to do any kind of analytics. And that's where our common data provider comes into place. So it's all about getting access to all of that information in real time. I know kind of historically, a lot of customers have done batch loads or looked at data 24 hours old. And, we're not in that place where that's really useful to us anymore. Things are rapidly changing and rapidly evolving. So we need to get to a real-time solution. The big premise of what Common Data Provider does is it'll go and read all of that data once and then stream it out to whatever platform or platforms we need to be able to do our analytics. And it supports all of the standard IBM SMF types, IMS log data, decollect data, RMF3, log data, all of that digital exhaust or operational data that's coming off of the platform, to make it available to where we want to go and do analytics. We do support some third-party types of SMF data, specifically around security like ACF2 or top secret, but it is an extensible solution where we can go and add new and additional data types. We give you full control over your data. So we have a lot of advanced filtering capabilities that I'll talk about that lets you kind of go and manage that data. And one of the key things that I've pushed the development team to do is really focus on performance. And we can't have these great solutions if they just go and chew up CPU and are a drag on the system. So we've really focused on making this as thin as a collection and streaming services as possible. And one of the significant achievements the team has done is that 100% of the runtime components are eligible to run on ZIP processors. So if we kind of look at a couple of things on this chart, first, the kind of on the left side, the evolution of where we started. We really started looking at just collecting SMF and log data, and quickly we expanded out to some of the other data types. But what we started seeing was that a lot of the other solutions across IBM Z needed to start having their data streamed out to different analytics platforms. So performance capacity analytics or ZOS Connect, IMS Connect extensions, all had started having requirements to get their data out to platforms like Splunk or Elastic different IBM platforms. We could also support a number of different things like Sumo Logic, Hadoop, Kafka, Syslog by sending data out to Logstash. We also do a lot of this data collection and processing on platform as well. So if you're attending the session around machine learning that I'll do tomorrow, we'll go and talk about how we stream data into DB2 for the purposes of integrating with Watson machine learning. So this entire ecosystem continues to grow, and really at the core of that is our common data provider, who's really built to make data available to all of these different platforms. So just quickly on kind of the architecture side of this, there's really three primary components of common data provider. We have our system data engine, which is responsible for processing SMF data. We have our log forwarder, which goes out and gets log data, and both of those feed data through our data streamer, which goes out and sends data to its final target, whether it be Splunk, Elastic Stack, Logstash, to go to a multitude of other places. So a very simple topology. We have a configuration tool that's UI based. I'll talk a little bit about that in just a moment, but very easy to be able to go and select and configure what data you want to go to which target. Splunk is a kind of a different case for us. We've had a strong partnership with them for quite a number of years now, and we actually have a highly optimized integration with Splunk. I know, especially here in the US, a large majority of our IBM Z customers have Splunk somewhere across their enterprise. And in talking to a lot of the customers that I've engaged with, even across the EU and Europe and the UK and the Middle East, a lot of them have Splunk as well. It's a little bit less pervasive than here in the US, but we've really tried to build a best of breed solution around this. And it's really around getting data into that platform in the most efficient way. And we've done this through use of a data receiver that captures Z data coming off platform and writes it out to CSV files. And the benefits that we get are really across a variety of different ways. First, it reduces the CPU on the Splunk infrastructure. It's much easier for Splunk to ingest CSV data than it is, say JSON. The other big thing is with that JSON data, it's much more verbose than CSV. So you have all of the different metadata that's in there that goes and brings up the amount of data that has to go across the network, that has to be stored. But Splunk has largely historically charged based on the amount of data that's been ingested. So if we have all of this extra metadata in the JSON data that's flowing across, it just explodes the amount of data going into the platform. And using our data receiver and CSV, we can reduce that by roughly 3 to 8 times, depending on the amount of or the type of data that's flowing in. And for our customers, it's really one of two benefits. If they know that they just want to take security records and some kicks in z/OS Connect, we can reduce that data volume 3 to 8 times, depending on the records. Or if we have a fixed license capacity for IBM Z, say 300 gigabytes or a terabyte, we can send that much more data from different data sources to provide insight and value into IBM Z. So going in and taking a quick look at the configuration UI, it's really built such that all of the different data types are organized across subsystem or logical groupings. So we can go and see if we want to take security data or kicks or IMS or DB2. We have the notion of what we call starter sets. That's really more akin to what's the most common information that our customers want to stream and get access to. So we can go and checkbox all of the different types that we want. We just assign them to a target. So whether it be a Splunk environment or Elastic environment, or if we need to stream our machine learning data over to DB2, we can just send which data to which targets. And we're really off and running. And what the configuration tool actually does is it generates a set of policy files that go out and get deployed to the runtime components of common data providers. So very easy to go and to configure and pick which data sources that we have. So I mentioned one of the key things that we had focused on was zip enablement of the components. And one of the components I mentioned as I was going through the architecture quickly was our system data engine. And this is what processes SMF data. And we found that in some of our lab tests that 99.79% of that workload was eligible to run on zips. So a very significant amount of the processing was offloaded off of the core processors. And there's a note there at the bottom, always the disclaimer when we go and put out numbers like this based on performance is essentially your results may vary, but there's a kind of the specifications that we went through. So we were reading from an in-memory resource. We did roughly 300 gigabytes of data from an LPAR of SMF 101s and 110, so DB2 and KICS records. You know, having zips online, and we were on a Z14 and z/OS 2.3. So, you know, a pretty standard configuration for what a lot of our customers might be looking at. So again, very significant results. So the last thing in talking about, you know, getting access to the operational data is one of the things that I really want to focus on is that middle bullet and the data filtering. And I know some of our customers have historically been nervous about sending Z data off platform over privacy concerns and data security. And we've built a lot into the solution to really give you full control over your data, so that, you know, we can kind of maintain any kind of data integrity or security best practices. And we can do that through two different levels of filtering, especially for SMF data. The first one that I'll talk about is field level filtering, where we can only send the parts of the record that's really needed in the target platform that we're sending data to. So if we think of sending data out to Elastic Stack, we may not need all of the 100, 150 or so fields from a KICS 110 record. In that case, we can only send the 10, 20, 30, or whatever fields that we want to drive the analytics that we're doing. If there's something that's sensitive data or information where we don't want to expose that off platform, we can easily pull those fields out and stream only the data that we want. So this is another way that we can actually reduce the amount of data and data volumes that are, that have to go across the network, that have to be stored, or in cases like Splunk, where they have to go and drive up those data ingestion charges. The other level of filtering that we support is record level filtering. And think of this as almost like a where clause or a way to specify specific instances of data that we want to go and stream. This is something that we actually built with one of the large banks here in the Southeast US, where I am. And their use case was that they wanted to look at KICS transaction records, so SMF 110s. They wanted to send those to their Splunk environment, but they didn't want to send the thousands of records per second to that environment and overwhelm the system with data. What they wanted to do was send only the data that was from some of their key business transactions. So they knew that the prefix of those KICS transactions, and they really only wanted to send the ones that were either long running, so ran longer than 2 seconds, or ended in abend. So they almost wanted to treat this as looking across all of those KICS 110 records and pulling out just the ones that match those, almost sending those like events to their Splunk console. So a great use case only to again get down to just the data that makes sense to drive your analytics use cases. So now that we've talked about, getting access to the data, I want to focus more on, kind of what we do with that. And we have our Z Operations Analytics solution that is really focused on a couple of different facets. So both of them leverage our common data provider to get access to all that operational data. The ones I'm going to focus on in the presentation today is really about gaining hybrid cloud visibility by integrating operational data with the rest of your enterprise, and really what that does for us. This will help expand our domain expertise and, driven through a lot of the dashboards that we have. Again, it's really around that problem identification phase so that we can do some of those handoffs, just like we saw with the APM solution. Our Z Operations Analytics solution also has a lot of machine learning built in, and that's really going to be the focus of the session that I'll talk about tomorrow. So if we look at, again, the problem identification, it's all about integrating IBM Z into the rest of our enterprise data. And as I mentioned, a lot of our customers, in addition to the application performance management solutions they have deployed across their enterprise, most, if not all, leverage a platform like Elasticstack or Splunk across their environments. And what we've done is we've integrated our operational data into those platforms, but we've also done a lot of that heavy lifting or groundwork that's needed to make mainframe data usable in these platforms. So I talked about common data provider. We've taken a lot of that data and done a lot of that pre-filtering of information, or what we call data curation, and doing a lot of the advanced calculations or around that. So figuring out things like IO rates and paging rates and response times. Instead of having it split across multiple fields, we do all of that calculation on platform so that once it gets to its target destination, it's in a very usable state. So we provide a set of out-of-the-box dashboards, and I'll do a brief demo just to kind of show some of the ones that we've built here in a little bit. But really across the entire ZOS subsystem stack. So looking at WebSphere, DB2, KICS, ZOS Connect is one that we've just added support for. In terms of, again, problem identification, there's a lot of quick searches that we can go and take a look at. So if you think of someone looking at all of this operational or log data, or even in a DevOps scenario where I've built a new application, but my API calls are failing on the back end, by bringing in information like syslog data, I can go and easily do quick searches. Am I starting to see, kicks add messages, or am I starting to see MQ channel issues? All of that information can be here by bringing this into a single location. And this really helps, again, that enterprise ops or DevOps use case. So there's also something that we have, and I'll go deeper into this one as we go in tomorrow, is our problem insights. And this is where we start to bubble up or aggregate a lot of the things that we're seeing that are happening on platform. So there's a set of messages that we're looking for if we're starting to see short on storage messages or MQ channel issues that will bubble up to this console that we can go and see, okay, I'm seeing something on this Sysplex, and I can go and take a look at my subsystem and see exactly what's going on. Am I starting to see errors coming in on that? All of our machine learning ties into this as well. And I can go and start to look at suggested actions, what are my next steps I can go and take. I can go out and what we call our evidence, and this is really the deep dive into either looking at the log or operational data, or out to some of our machine learning scorecards that we have. But it's really an aggregator to bring everything that we see happening through all of that operational data into one single place. So just one other thing about kind of why this is important, and something that we had done with the Splunk team when we first started building the integrations and proof of concepts. And Splunk has something called IT service intelligence. And this really ties together a lot of different views into operational data. And the visualization that we built, they like to use a fictitious company called Buttercup, and this was a case of using Buttercup Bank. And what they wanted to show that we could model potentially is, we have two different tiers of customers coming in to access their core banking infrastructure, either coming through online or through a mobile devices, as many of us do now. And the whole idea behind this is you get these glass tables that show at a very high level the overall relative health of your system and environment. And it's bringing a lot of different KPIs together. So we can see that, if I was an application owner, I'd be very concerned seeing that I have no customers coming in through either of my tiers. It's not doing any kind of revenue generation for me. But I can go and look at through the KPIs that have been defined for the piece of the infrastructure, that my API level is okay, my mobile tier and web tier aren't very healthy, all the way back down to where I might be seeing some processing on the mainframe that's having some issues. I can tie these back to IT services, so I can look at my login status. My logins might be red or offline. So a very easy way to tie together not only IT pieces, but you can also start bringing in KPIs and metrics to start to show a business view as well. So something that's very nice and visual for our customers. If I jump over to just to kind of quickly show some of the dashboards and things that we have that are really kind of important in terms of looking at IBM Z in context of hybrid cloud. So this is Splunk. We have the same content available in Elastic Stack as well. But if I go and take a look at, for example, my ZOS Connect enterprise dashboard, I can see my entire API economy on a single dashboard. The workload that we have running here is on the smaller side. It's not a large number of APIs, but I can see the number of transactions that are getting called against each one of my APIs. We had a big dip here that happened shortly after noon, so maybe something had happened there. I can go and see my average response time. So for some reason, I had a large spike in response times here. I can see the data rates and error rates that are happening for different APIs. So something really happened to my stock manager API here just after 4 o'clock. And I can always go and drill down into the specific API layer and just go and click on this one if I want to go and take a look at this specific one. And this is my stock manager API. And I have a price query and a stock query inside of that. And I can see that I had a large spike of those happen right around what would be market close here in the US on around 4 o'clock. So maybe we had a large number, and it's interesting that it corresponded to a large number of error counts as well. So we're getting different error codes coming in through this 500, so service not available, which would be terrible right around the time of market close. So an easy way to go and look at the health of my APIs. And if I'm sitting here putting on my DevOps hat and I'm an application owner or application developer, I can quickly see that, where the problem is going on within my applications or API calls. So ZOS Connect was a very important one for us to go and build and provide support for. I can also go and look at the service dashboard. That's actually what I was just in to pull those in. So I have all of my different services at kind of the top level. I have these filters that I can go if I wanted to specify a certain set of information. If I wanted just a specific API, I can go and drill into those specific details. So you're always close to the actual operational data. So these are the ZOSMF summary records that we're bringing into the platform. So we can go and see all the different details that we're seeing for this. So we're getting a lot of gets and really a lot of information that's coming from those ZOSMF 123 records that ZOS Connect is generating. So I mentioned our ability to go and look at searches. And again, we've broken these out across a variety of subsystems. So if I wanted to go and take a look at, for example, DB2 messages, I can go and just take a look at all of my top level DB2 messages that happened over the last 24 hours. So this is looking at, all of the different things that I've had coming from syslog, and go and take a look at the data that's here. So if I was experiencing an application issue, I can always go out and look at, MQ. Do I have any buffer pull error messages? So common MQ issues that we might go and see. So if I'm trying to, again, identify any problems within an application, I can go and quickly take a look and start scanning through some of this information. So I've had no buffer pull issues. I might have some general MQ messages here. So we can see that, one of our agents ended abnormally. There's, everything that's coming in from MQ that we might need to go debug or look at application issues. And, the big benefit is that we're bringing everything together across our entire hybrid cloud, whether it be running on IBM Z or whether it be running somewhere in the public cloud. We can bring in all of that information here and look at things in a single context. And this is really beneficial to helping all of you really understand how these key applications are working together. So I'm going to jump back over quickly to my slides and really just to kind of summarize what I've talked about today. I've tried to leave about 10 minutes or so if we have any questions. I haven't seen any in the chat just yet, but we really talked about 3 key pieces of the infrastructure that are built around completing this hybrid cloud story. our IBM Z Application Performance Management Connect, which lets our customers go and visualize their hybrid cloud applications and transactions across the entire enterprise. So we have a good way to complete that picture by looking at IBM Z. Getting access to all of the operational data on platform with our common data provider. And with our Z Operations Analytics is how we start to go and analyze all of that data within an analytics platform. So really a set of different solutions that really start to integrate with a lot of these tools that are already deployed across most of our customer enterprises. So there's another slide here, and I saw the question and comment that's there, and I'll come back to that in just a moment. That we can go and look at. There's a Z trial for ZAPM. There's information to go out to all of the product pages. We have a case study from one of our customers in Croatia. Opus IT has done a lot of great things around integrating IBM Z into their Splunk environment. So a really good case study to go out there and talk about and how they realized a lot of the things that I've talked about today, and really simplifying IBM Z and their mainframe to their enterprise IT solutions. We have a set of newsletters just to stay up to date on events such as this, or product announcements, or technical content that goes out around a lot of the platforms and solutions. And I'm going to go and do my pitches for Anna now. I know that she'll be happy to go through and talk to these. So I know one of the things they're always trying to strive to get is feedback. So this session was 5AZ. So please go and do the session feedback. All of these slides are available for download. So if you want to go and take a look at those, I've included screen captures for a lot of the things I went through as part of the demo in the Splunk environment as well in the slide deck that's posted. Just to quickly about the ZOS or the GSE 2020 charity. So donating to the charity, there's the link and QR code to go and do that. And with that, I'll go ahead and Morton, thanks for posting your comment to the chat. So it was really around having a large amounts of KICS transactions during peak days. So 350 million transactions per day. So generating 750 to 800 million SMF records across 48 LPARs for 7 different customers. So that's an awful lot of data, and not uncommon for what we've seen for a lot of our bigger IBM Z customers. And in terms of operational data, the way that we handle those things is that's way too much data to send to any analytics platform. We started looking at doing it for medium-sized workloads going into Splunk, and that volume of records, the searches start taking very, very long to go and do that. So what we've done is there's a couple of different ways that you can really start to take advantage of this. One is you can filter out data that's really the specific things that you're looking for to get out of this. In the case of the banking customer that I talked about here in the US, they just really cared about KICS transactions that were from core applications, or ones that served certain signs, in their case, either long running or ended in add-band. So we can do that kind of record level filtering to really just pull out on platform the data that we really need. The other thing that we've done, if I go back over to my demo environment, is we do have a set of dashboards for CICS. And if I go and take a look at my enterprise dashboard, we can kind of see all of the top transactions that are happening across the entire enterprise. And this is, again, a pretty small environment for kind of demo purposes, and not a very large transaction count. But instead of sending every single 110 record, we have a set of KPI records that we send. that goes and summarizes that KICS data. I believe it's on a minute boundary, so that we're not sending every single record. We're just sending the key statistics that are summarized over a period of time. So this makes it much more usable once we get into a platform like Splunk or Elasticstack, where we're not overwhelming the system with such that large number of messages. So Morton, so your point is very well taken, and something that we've certainly tried to address within the solutions. Z, as I mentioned, is one of the most well-instrumented platforms that's out there, and we really try to take advantage of it in the best way that we can in terms of how we go and manage data. So are there other questions or comments? Do folks like what you guys have seen? We've seen a lot of really good customer success kind of integrating IBM Z. And if you look at even what IBM is focused on is all about hybrid cloud. And we're going to see that IBM Z is going to play a bigger and bigger role as part of that, because I don't have to tell all of you, our mainframe experts, how important IBM Z is to your environments, and really what runs a lot of the world's economy on this hardware.
Okay. Well, if there are no more questions, I can just, let's try this. I can allow you to unmute yourself. If you want to unmute yourself and actually ask a question rather than put it in the chat, please feel free. As Dan mentioned, please, small donations to the GSE charity will be greatly appreciated, and also feedback, always appreciated. So I shall shut up now and allow you to ask Dan any specific questions that you want, including when is your session tomorrow, Dan?
I believe it's at 8:30 my time, so that would be
God, 8 plus 5.
1:30.
1:30.
So 13:30 tomorrow.
It could be 13:30. Is it 3BD?
That's a good question. I'll tell you in
Well,
one
not
moment.
to worry. I'm sure everybody can find it in the agenda.
Yes, that's it. It is 3BD.
Okay, I thought, well, that was the one that I had at 13:30, so we've got a match. So hopefully see the rest of you for the follow-on session with even more detail at 1:30 UK time tomorrow. I hope you've had a good GSE day today. I think there's just one more session left, but not for me. And I hope I will see most of you again tomorrow. Still no one wants to rush in with a question. Okay, so in that case, my thanks to Dan, my thanks to all of you for attending, and I will close the session now. Okay, goodbye.
Thank you, Anna.